Good morning, students. Myself, Pragnesh Polara from Roma Engineering College, Junagadh. Today we are meet here for a big discussion on complex numbers. Till now, we all are very well aware about the natural numbers, then the set of all integers, then rational numbers, irrational numbers, real numbers, like that. But till now we have not discussed about the idea of a complex number. So today we will discuss on the idea of complex numbers. So let us first look about what is the idea behind the complex number. Okay, so this is the main question in our mind, that what is a complex number. So first of all, I want to tell you that it is a tool to solve an equation. As we all know that the real numbers, rational numbers, natural numbers, all comes from the idea of solving an equation. Okay, so this is also one kind of tool to solve an equation, and it has been used to solve equations for the last 200 years or so. What is the main idea behind the discussion of a complex number? That is, until now you have always been told that we cannot take the square root of a negative number, but that is right for the real numbers only. If you talking about the real numbers, then you cannot find the square root of a negative number. But if you are going to use imaginary units, or I can say complex numbers, then you can find the square root of a negative number. Okay, so this is the main idea behind the complex number. So this is the imaginary unit. The imaginary unit is I, and it is defined to be I such that I square is equal to minus or I can say I is equal to in root minus 1. That means the square root of a minus 1 is I, but not that I is not a real number, it is an imaginary number. So if you want to find the square root of a minus 1, then that is equal to I. Okay, or I can say I square is equal to minus 1, and it is used to write the square root of a negative number. Now onwards, if you want to find the square root of any negative number, then by the use of this imaginary unit you can find the square root of that negative number. Okay, let us look at the property of the square root of any negative number. If r is a positive real number, then if you want to find the square root of minus r, then note that you can write minus r is equal to minus 1 into r, and minus 1 is equal to I square, so that is in root I square into I, and the square root of I square, that is I, so answer is equal to I in root r. Okay, let us look at some examples. If you want to find the square root of minus 3, then minus 3 is equal to 3 into minus 1, so you can write the square root of minus 3 is equal to I into root 3. In the same way, if you want to find the square root of minus 4, then that is 4 into minus 1, so 4 into I square, root of I square is equal to I, so that the answer is I into root 4, and root 4 is equal to 2, so square root of minus 4 is equal to 2i, right? So in this way we can use the idea of a complex number, or I can say the imaginary number, to find the square root of negative numbers. Okay, let us move ahead. Let us try to understand the idea of complex number. What is complex number? What is imaginary number? So here I can say I is an imaginary number, or I can say I is a complex number, or I can say I is an unreal number. All that terms are interchangeable. I can say the imaginary number, or I can say a complex number, or I can say a unreal number. So all have the same meaning, which is the complex number. Normally we like to say I is a complex number. Okay, so now this all our lectures depends on that the complex number I. Let us look about the PPT. These are some observation for the complex numbers. First, in the beginning there were only the counting number, that means the natural numbers, that is 1, 2, 3, 4. This all are natural numbers. And then we needed some integers, that is negative numbers, that is -1, -3. So 1, 2, 3, 4 all are belongs to n, which is the natural number set. Then we need integers, which is -1, -2, -3, all these numbers belongs to z. Z is a set of all integers. Here the green circle is for the natural numbers, and the yellow square is for the need of for the integers. Then we add the rational numbers, as here I denote with the 0.41, which is the rational number. Then we need irrational number, which is for example √2, √3, √5. all are irrational number, that all belongs to the real numbers, right? So till now we have always discussed about these numbers, like counting numbers, integers, rational numbers, irrational numbers, like that. But we have always used them where to fit the unreal numbers, or I can say which numbers are not reals. So where do unreal numbers fit in? So we have always used them as a complex number, but we have always like to write 6, but 6 is not just 6, it is 6 plus 0i. Complex number incorporate all these numbers. Okay, so complex set is the master set of all this set of natural numbers, in set of integers, rational number set, or real number set. The complex number set is a master set, right? So here orange square is for orange part is for the complex numbers. Okay, so this is the idea behind the complex number. So this is some statement for the complex numbers. A complex number has two parts. First part is a real part, and the second part is an imaginary part. Okay, the standard format of a complex number is a plus ib, or I can say a plus bi, where the number I is called the real part of a complex number, and the part B, which is the coefficient of I, or I can say multiple of I, it is called the imaginary part of a complex number. So this is the standard form of any complex number. We will write any complex number in this way, like a plus ib, where a is a real part and b is an imaginary part. So this is how can we write the complex number. So we can write complex number. Normally we like to use the symbol z for any complex number, so we can write the complex number z is equal to a plus bi, where a is a real part of z and b is imaginary part of z, right? For example, if we want to find this is the complex number 5 plus 4i, then 5 plus 4i is a complex number where 5 is a real part of that complex number and 4 is an imaginary part of a complex number. Okay, not that a number such that 3i is a purely imaginary number, because there is not any real part, because the general way to write any complex number is a plus ib, but here 3i is, there is only ib, there is not anything like a, because here a is equal to 0. So if we look at the PPT, then here 3i is only imaginary number because there is not any real part, so that there is a real part is equal to 0. We can write that 0 plus 3i, where 0 is a real part of this complex number and 3 is an imaginary part. Okay, in the same way, if we discuss about the number 6, then 6 is a purely real number because there is a, we can write 6 as a 6 plus I into 0. So 6 is a real part and imaginary part is 0 in this number. So we can say that 6 is a purely real number, but we can write into this number as a complex number. Okay, 6 plus I into 0, where 6 is the real part and 0 is a imaginary part of this complex number. Okay, 6 plus 3i is a complex number where so we can say that a plus ib is the general form of a complex number, right? If we want to discuss about the real part and imaginary part of the number 6 minus 4i, then a is equal to 6 and b is equal to minus 4i. So here 6 is a real part and b is equal to minus 4 is an imaginary part of this number. Okay, so we can say the real part of 6 minus 4i is equal to 6 and the imaginary part of 6 minus 4i is equal to minus 4. થોડા પાછા આગળ જઈએ અને ડિસ્કસ કરીએ આઈ વિશે. આપણે ઓલરેડી ડિસ્કસ કરેલું છે કે આઈ ઇઝ ઇક્વલ ટુ રૂટ ઓફ -1 થશે. સો આપણે એ પણ ડિસ્કસ કરવું પડે કે આઈ સ્ક્વેર, આપણે ઓલરેડી ડિસ્કસ કરેલું છે કે આઈ સ્ક્વેર ઇઝ ઇક્વલ ટુ -1 થશે. બટ ઇફ વી હેવ I cube, I raised to 4, I raised to 5, then we need to convert in the format of either I or in a I square, that is equal to -1. So if we have I cube, then I cube, we can write I cube is equal to I square into I. So I square is equal to -1, so we can write I cube is equal to minus I. In the same way, I raised to 4 is equal to I square into I square. That is -1 into -1, that is equal to +1. In the same way, I raised to 5 is equal to I raised to 6, that is equal to -1, that is equal to I square. I raised to 7 is equal to minus I raised to 8 is equal to 1, etc. In the same way, we can find any power of I very easily. Generally, we can say for a larger exponents of I, so for that we can divide the exponent by 4 and then use the remainder as your exponent instead of that larger number. For example, અહીંયા હું એવું કહેવા માગું છું કે ફોર એક્ઝામ્પલ જ્યારે આઈની બહુ મોટી ઇન્ડેક્સવાળા કોઈ ટર્મ હોય અને આપણે એનો આન્સર મેળવવો હોય ત્યારે જે આઈની જે પાવર હશે એને આપણે 4 વડે ડિવાઈડ કરશું, કેમ કે I raised to 4 is equal to 1 થઈ જાય છે. તો આપણે એને 4 વડે ડિવાઈડ કરશું અને પછી જે રિમાઇન્ડર વધશે એને આપણે જે પાવર હતો એની જગ્યાએ આપણે રિમાઇન્ડરને મૂકી અને પછી આપણે એનો આન્સર મેળવશું. ફોર એક્ઝામ્પલ, જો આપણે i⁻23 કાઉન્ટ કરવા માગતા હોય તો ફર્સ્ટ આપણે i⁻23 માંથી 23 ને 4 વડે ડિવાઈડ કરશું. સો 23 ને 4 વડે ડિવાઈડ કરશું તો આન્સર આવશે 5 વિથ રિમાઇન્ડર 3. સો હવે આપણે i⁻23 નહીં પરંતુ i⁻3 નો આન્સર મેળવશું, અને જે i⁻3 નો આન્સર થશે એ જ i⁻23 નો આન્સર થશે. સો અહીંયા રિમાઇન્ડર છે 3. સો i⁻3 that is equal to minus I, as we have discussed in the left hand side, I cube that is equal to minus I. તો અહીંયા i⁻23 નો આન્સર પણ minus I થશે. ઓકે, i⁻23 is equal to minus I. તો હું પાછો તમને કહી દઉં કે જ્યારે આઈની કોઈ પણ મોટી પાવરવાળું ટર્મ હોય અને એનો આન્સર આપણે મેળવવો હોય તો આપણે જે આઈની ઇન્ડેક્સ હશે એને આપણે 4 વડે ડિવાઈડ કરશું, અને જે રિમાઇન્ડર વધશે એ રિમાઇન્ડરને આપણે જે પાવર હશે આઈની એની જગ્યાએ રિપ્લેસ કરશું. અને આપણે ખબર જ છે કે રિમાઇન્ડર વધશે આઈધર 1 or 2 or 3. ઓકે, સો I is equal to root of -1, I squared that is equal to -1, I cube that is equal to minus I. અને જો તમે 4 વડે એને ડિવાઈડ કરી શકતા હો then એનો આન્સર આવશે i⁻4 is equal to -1. ઓકે, સો આપણો આન્સર આવશે 1. જો તે ફુલ્લી ડિવાઈડ હોય તો there is not any remainder, then the answer is a +1. So in this way we can find the index of I, any index of I, then we can find the power of I is in this way. Okay, here there are some examples of on the complex number. First, if we want to find the square of I into √3, then square of I into √3 that is equal to I square into square of √3. So we know that square of √3 that is equal to 3, and as we have discussed previously that I square that